Hello, everyone. In this video, I will introduce DBPack, which is the DBMesh solution implemented in EAT transaction model. And for more information, you can refer to below GitHub repository. Next slide. Sorry. So what is EAT transaction? In EAT transaction means event-driven AT transaction. And for AT transaction, it means automatic transaction by auto compensation. So what is our AT transaction? AT transaction is a distributed transaction solution that allows branch transactions to commit with undo lock. And in case the global rollback happens, the branch transactions will roll back with by the undo lock to recover to the original status. In case global commit scenario, it will delete the undo lock on the branch transaction. So there is so this function is implemented by the resource manager, and which is a database driver that allows the database to commit with the undo lock, which is the before image for the local transaction. So the AT transaction has three modules. One is the transaction manager. Its main function is to send requests to begin the global transaction, and also send requests to global commit and global rollback. For the transaction coordinator, which is TC, it begins the global transaction. It will also commit and roll back the global transaction. It will also detect the global transaction timeout and try to roll back the transaction. And for resource manager, it registers branches, and after the transaction the branch is registered successfully, it will commit the local transaction with the undo lock. And in case global transaction raw commit, it will commit the branch transaction by deleting the undo lock. And in case global rollback, it will roll back the branch transaction by executing the undo lock in stored before. And here is a flow for our AT transaction sample. So first, user sent API request to the aggregation service. We have three services here. The aggregation service will call the order service and product service, and it will know if the microservice API call is success or not. And the aggregation service is a caller which calls order service and product service. So firstly, user send request to aggregation service. The transaction manager will know that it needs to open a global transaction, and the transaction coordinator, the TC server, it will generate our global transaction for it and returns the XID to transaction manager. The XID is a unique transaction ID for the global transaction. And after we retrieve the XID, the transaction manager will send request to order service with the XID. And so the order service, the resource manager on this order service, it will send branch register request before committing its local transaction. So after this, the TC server will have a branch session lock to lock the branch transaction of order service. So the data will be locked by the TC server, and it will return the branch ID to order service, and the resource manager will commit the local transaction with the undo lock. After that, the aggregation service know that it can continue the products, continue to call the product service, and it send request to the product service with XID, and the similar to order service. It will the product service will send the branch register request to TC server, and the TC will also lock the data for the product service, and it will return the branch ID. So in this time, if there is, for example, it commit the local transaction with undo lock failed. So in case failed, and the results manager will send the branch report request to the TC server, and the TC server will release the branch session log for them and for it. And then the aggregation service will know that there is an error during the order survey, during the production service calling, and it will send the global rollback request to the transaction coordinator. The transaction coordinator will find all the branch transactions that successfully committed before, and it will send the branch rollback request to them. For example, in this scenario, it will send the branch rollback request to order service, and it will the order service will commit with the it will roll back the transaction with the undo lock to recover the data status to the original status. Yeah, and the global transaction and branch and the global transaction and and the log data is stored on the TC server side. So this is the sequence flow for the upper example. So for first, the client send the API request to transaction manager, which is on the aggregation service. The TM will open the global transaction, and the TC returns the XID, and the TM will the aggregation service will request order service, and the order service will do the branch register from the TC server, and after success, the TM will request the product service to send API request to product service. The product service will register the branch, and then it will send the response to TM, and transaction manager will know that if to global commit or global rollback the transaction. So the TC server will know will get updated. The global transaction will status will be updated, and then the branch commit it will send branch commit or branch rollback request to each service. And in this slide, I'm going to introduce the pros and cons for different transaction models. And for traditional XA transaction, which is a two-phase log transaction, the performance is low, and it has no invasion to business. It supports any language, and but it does not support DB sharding and table sharding. For the TCC service, for the TCC transaction model, the performance is high, and but it has invasion into the business logic. So each service has to prepare the try API and the cancel API for it. And there is some more database update for this TCC transaction model, and it supports any language, but it doesn't support DB sharding and table sharding. For the Saga, it is similar to TCC. And for AT transaction, and the performance is also high, and it has invasion to it has no invasion into the business, and but the language support is specified. So for Java version AT transaction middleware, it only supports the microservice language to be Java. So it does not support DB sharding and table sharding. And for the event-driven AT transaction, the performance is high, and it has no invasion into the business, and it supports multiple language, and it also supports DB sharding and table sharding. In next slide, I will introduce more. So why I will introduce more about why does the AT transaction only supports specified programming language, because so for AT transaction middleware, different languages have to implement their own resource manager and transaction manager, so that the RM and the TM can handle the communications between modules. And for example, the AT transaction middleware is implemented in Go language, but some PHP microservice want to use AT transaction, then developers need to develop the RM and TM module for PHP. Okay. And currently on GitHub, there are some AT transaction middlewares implemented in Java, Golang, and Python. And for more information, you can open this link to explore more. So to resolve the AT transaction only supports specified programming language, the issue. To resolve that issue, we have come up with the transaction mesh solution. So imagine we have a sidecar on each microservice. For example, we have Go service here and Java service there, and we have a sidecar for each microservice. In this sidecar, we have our MySQL proxy, which will intercept the MySQL traffic and do the undo log and prepare the undo log and manage the AT transaction for them. We have our event distributor here, which can update the transaction status between different sidecars here. So in this way, we can implement a transaction mesh. For in this picture, it is MySQL transaction mesh. And for if we can implement different drivers in the database sidecar, we can say that we can implement the DBMesh in the microservice. So for the DBMesh, we support different MySQL different database drivers, such as MySQL and SQLite, SQL Server, Oracle, and so on. So here is the DBPack, which is the DBMesh solution for cloud native environment. So in our DBPack, we set the event distributor to etcd, and currently for DBPack, we have implemented the MySQL proxy sidecar for the distributed transaction. And for example, the Go service here, it has the MySQL proxy sidecar, and Java service here, it has also the MySQL proxy sidecar. In the future, we will implement more MySQL drivers. We will implement more DB DB drivers proxies for the sidecar. And what problems does DBPack solve? First is the distributed transaction, and it also supports the read-write splitting and the database sharding, table sharding. It also supports any programming language without any limit compared to AT transaction. And it also, it supports EAT transaction model and also the TCC mode. And we have the performance is very high. Since we are using the etcd watch mechanism, I will introduce more later. So it also has no invasion into the business logic. So by setting the sidecar for each microservice, the distributed transaction can be finished without any business logic invasion. Yeah. So for the DBPack architecture, we have filters, executors, and listeners. For the listeners part, we have implemented MySQL, and in the future we plan to implement the PostgreSQL and the Oracle and so on. For the executor model, we have implemented the single DB mode and the rewrite splitting and sharding. For the filters, we have implemented the distributed transaction, the metrics, audit logs, the encryption and depression, and the circuit breaker. I think they are still on the way. And here is the EAT mode in DBPack. I'm gonna introduce this flow for you to have a better understanding of the DBPack workflow. So first, user send the API, for example, API request to the aggregation service. And the DBPack, which is the sidecar on the aggregation service, it will generate the XID and create the global transaction data on the etcd server. Yeah, we have the global session here. And then we use the XID and we pass the XID. For example, by HTTP headers, we send the XID to the order service by calling the order service logic, the API. Also with the XID, the DBPack, it will send to firstly the request sent firstly, the request was sent to each service, including aggregation service. The request is sent to the DBPack firstly, then handled to aggregation service. So the DBPack will proxy everything for them. So continue. So after the XID passed to the order service, the DBPack will register the branch, will create the branch transaction in the etcd side. And it will also commit the local transaction with the prepared undo log. Yeah, the branch session is stored in the global session. And we have the XID. And after the order service calling success, the order service will call the product service, and DBPack will get the XID, and it will create the transaction branch for the product service. And we have a branch session in the etcd. Then the product service will respond to the aggregation service. So if both order service and product service are success, the API are both success, the aggregation service will the DBPack will raise the global commit or rollback request to the it will store the global commit and the rollback status in the etcd. So the global session, which means the global transaction, the status will be updated to committing or rolling back status. And the via the etcd watch mechanism, the order service will know that the DBPack will know that the global transaction status has been updated to committing or rollbacking. For example, rollbacking, and the etcd watch event will send to the DBPack. The DBPack knows that the order service should roll back its branch transaction. The same for product service. So the product service and the order service will use the undo lock to roll back the local transaction to the original status. Yeah, that is the event-driven AT transaction mode. Yeah, I think that's it. And thank you for listening. Sorry for my poor English. And for more information, you can explore these GitHub repositories. And for the DBPack demo, the samples here, we have implemented the Java, Go, PHP, Python, and .NET examples for you. So if you want to know how to use DBPack to, if you want to experience the demo, you can go to this repository. And yeah, the documents, we are also improving the documents for English version, and more features are coming soon. So we sincerely hope if you are interested in this project in DBPack, please join us. And if you have any other questions or concerns, you can also raise the issues in our DBPack repository. We are very glad to reply to you and solve things for you. Yeah, I think that's all for the sharings. And yeah, thank you for listening. Goodbye.